So photoelectric effect refers to the phenomena which we observe when the light in the form of particles falls on the metal surface, and the particle which carry energy, the light energy, that particle is called photon. So light in the form of photon strike the metal surface. Electrons which are present in the metal, they absorb this photon, but whether they come out or not, that depends on the energy of the photon as well as the minimum possible energy needed to remove electrons. So this is energy of a photon, and minimum possible energy is known as the work function, denoted by phi. So if energy of the incident photon is less than work function, there will be no photoelectric effect. If energy of the incident photon is greater than or equal to work function, yes, there will be a photoelectric effect. So a question now related to the last session, as we discussed this in detail, the photoelectric effect. So a teacher demonstrates the photoelectric effect. So teacher is demonstrating the photoelectric effect means he shines a light from UV, ultraviolet lamp, onto a metal surface. Calculate the maximum kinetic energy in joules for photoelectrons from the metal surface. The frequency of ultraviolet radiation is 4.2 into 10 to the power 15 hertz, and the work function of the metal is given in 4.1 electron volt. Electron volt is also a unit of energy. So if we want to relate them by equation, the photon strike the metal, electron will absorb, it will use some of the energy to come out from the metal surface, and remaining energy is used as a kinetic energy. So we can say that the energy of the photon E is equals to the minimum possible energy needed to remove electron phi plus energy needed to remove the speed at which the electrons are coming out, that's called kinetic energy, the speed of the electrons. So in the question we have to calculate the kinetic energy. So this factor is unknown. So how to work out the kinetic energy? So basically energy of the incident photon minus the work function, we will get kinetic energy. The formula which we will use to calculate the energy of the photon, it is given by a formula E is equals to hf. So energy of the incident photon is equals to h, the Planck's constant, and f is the frequency of the light which is incident. So the value, the Planck constant, it is fixed, which is 6.63 into 10 to the power minus 34. And the frequency of the incident that is given in the question, that is 4.2 into 10 to the power 15. So 4.2 exponent 15. When we multiply these two factors, we will get the energy in joule, that is 2.79 into 10 to the power minus 18 joule. This is the energy of the incident photon. Now we have to find the work function. Work function is given, but in the question the work function is given in electron volt. We have to convert this electron volt into joule, because when we are subtracting the two quantities, they should be in the same unit. So how we can convert, work function is refers to phi. So how we can convert the electron volt into joule? We have the formula that 1 electron volt is equals to 1.6 into 10 to the power minus 19 joule. So if there is 1 electron volt, that is equals to 1.6 into 10 to the power minus 19 joules. So in the question, we have 4.1 electron volts. So how many joules will be there? X. Cross multiply. So 4.1 multiplied by 1.6 exponent minus 19. So this will give us 6.56 into 10 to the power minus 19 joules. So now we have the work function in joules. This X is actually the work function. So we have the work function, we have the energy of the incident photon. So we subtract to calculate the kinetic energy or maximum kinetic energy. So energy was 2.79 into 10 to the power minus 18 minus the work function is 6.56 into 10 to the power minus 19. So when we subtract the two factors, the final will be the kinetic energy, or the maximum kinetic energy will come out as 2.13 into 10 to the power minus 18 joules. So this is the kinetic energy at which this electron will come out. Is it clear, this question, that how we calculated the kinetic energy of the electron which is coming out from the metal surface? Any doubt in this question? Then in part B, the teacher replaces a ultraviolet lamp, UV lamp, with a more powerful energy source, which emit UV radiation of the same frequency, but more powerful source is there, like more photons it is emitting out. Why this result in more photoelectron being emitted per second? So this is a metal surface. We are using the same frequency. Same frequency means we are using a source of same energy, but that is more powerful. What does it mean? If this is a UV source or a UV lamp, say first it was emitting out 2 photons. Example. So one electron absorbs 1 photon at a time. So as a result, what will happen when 2 photons are emitted out from the lamp? So electron will absorb those 2 photons and they will go out. But now in the question, what we are doing, we keep the energy of each photon same. We are not changing their energy. What we just change, we use a more powerful. So using a more powerful lamp in terms of energy, what will happen? The energy in the question they mention, it remains same. The only thing what happened, the number of the photons will increase. So as we increase the number of the photons, more particles of the light strike the metal surface. So as a result, when we increases the number of the photon, so greater number of electrons absorb energy and they will go out from the metal surface. So we have to explain why this result in a more photoelectron emitted per second. So when we increase the power here, it means we increase the number of the photon per second. So increase in the power will increase, they will have a greater intensity. So higher intensity means there will be more photons in a unit time from the source. So there are more photons which are coming out from the source every second. And as a result, one electron absorb 1 photon. So the number of the electrons will increase. So you have to explain this observation. What happens if a teacher replaces a UV lamp with a more powerful one? So if the UV lamp is more powerful one, it means it is emitting out more photon every second. And as greater the number of the photon, we know in a photoelectric effect, one photon is absorbed by one electron. So increasing a number of the photon will increase the number of electrons which are, because more photons means more electron absorbed photon, greater the number of electron absorbed photon, greater the number of electrons will come out from the metal surface. So the photocurrent, or the current which is produced due to these electrons, will also increase. Is it clear, this part? That how increasing the power of the lamp increases the number of the electrons coming out every second? Another question In 1921, Albert Einstein was awarded a Nobel Prize for physics for his discovery of the law of photoelectric effect. What is the law of photoelectric effect? It states that when light in the form of particles, photons, falls on the metal, these photons, if the energy of the photon is more than the work function, these electrons absorb energy, they will go out. Minimum possible energy the electron need to come out, that's known as the work function. And remaining of the energy which electron absorb from these photon is converted as a kinetic energy or used as a motion. To explain this effect, Einstein proposed that electromagnetic radiation should be modeled as a particle rather than a wave. Means he suggests the wave nature cannot explain this photoelectric effect. As we know, light is having a dual nature. Light is having a dual nature. Some of the phenomena of the light can be explained by wave nature. Some of the phenomena of the light can be explained by particle nature. So the photoelectric effect can only be explained by particle nature. It cannot be explained by wave nature. So we have to explain why when considering a photoelectric effect, the treating electromagnetic radiation as a particle is more successful model than treating the electromagnetic radiations as a wave. And the weightage of the marks is 6 marks. So the question is simple. The question is why the wave nature cannot explain this photoelectric effect and why the particle nature is able to explain this photoelectric effect. So number one, according to wave nature, because wave is like a continuous supply of energy, according to wave nature, if light is having a wave nature, light is having a wave nature, but in photoelectric effect, it is not having a wave nature. It cannot explain that effect. It can only be explained by particle. So example, if there is an electron here in the metal and light was behaving like a wave, then what should happen? Because continuously the energy is coming to the metal surface. So as continuously the energy is coming to the metal surface, what should happen? This electron, a time should come that this electron absorb energy, and after some time it will have sufficient amount of energy and this electron should go out. But practically this we don't find. This does not happen. What happened practically? Then when we have a metal surface, if the photon, like when we compare light as a particle nature, so we say the particle which carry the energy, that is a photon. So when the photon energy or the energy of the photon is more than the work function or equal to work function, like example work function is 30 joule and energy of the incident photon is say 40 joule. So if photon is having energy more than the work function, electron absorb that photon and it will use remaining energy as a kinetic. But if the energy of the photon is less than the work function, like work function, there is a minimum energy needed to remove electron. So if energy of the photon is less than the work function, then even though electron absorb this photon, but it can never come out. So according to wave nature, any radiation, any kind of radiation can be able to remove the electron out. But according to particle nature, there is a radiation with a fixed amount of energy that can remove the electron out, not all the radiation. So practically when we observe, we find that photoelectric effect does not happen like this, that any kind of radiation, like I have a piece of metal, I use a blue light, red light, green light. So these all lights cannot emit out the electrons out, but if we use light as a wave nature, it should happen, but it is not happening. What we observe, there is a specific amount of energy which is needed to remove the electron out and which can only be explained by particle. It cannot be explained by wave nature. So this is one of the thing, that if it is a wave nature, if light was having a wave nature in photoelectric effect, this photoelectric effect should happen for any kind of radiation. And electron after some time should come out. But because what we observe, if the light is having a certain energy, it causes a photoelectric effect. If the energy is less than the work function, it does not cause a photoelectric effect. So practically we observe the particle nature rather than a wave nature. That's why we say light is having a particle nature in photoelectric effect. And the second thing, if we increase the intensity, so when we increase the intensity, what we observe more. Increasing intensity means more photons. So increasing the intensity will increase the number of electrons or the current produced. That is what we observe. So this is particle nature is supported by the practical observation rather than the wave nature. So when you will write the answer for this, what are the points which you should consider when writing the answer for this one? Number one, according to wave nature, there should be no threshold frequency or threshold or work function, and any energy should be able to, or any kind of light should be able to remove electrons from metal surface. So according to wave nature, there is no work function. But what happened? Practically, there is a work function. Practically, there is a minimum possible energy needed to remove electron. So there is a minimum energy required to remove electron practically. So that is the contradiction, that it does not support the wave nature. Practically, it support the particle nature. So practically, there is a minimum energy required to release electrons. Then according to wave nature, if light is having a wave nature, this effect will take time and electron is not released instantly. Like immediately the electron will not come out according to wave nature. But practically what we observe, that electrons released instantly. So instantly when the photon absorbed by the electron, if the energy of a photon is more than the work function or equal, electron immediately will go out. If it is not, then electron will not come out. And according to wave nature, the kinetic energy of electrons coming out should depends on intensity. So if light is having a wave nature, if we change the intensity of a light, the kinetic energy of the electron should change. But practically what we observe, increasing the intensity or changing the intensity will increase the number of the electrons but not their kinetic energy. Like high intensity means more photon. If more photons are there, there will be more electrons. So increasing the intensity changes the number of electrons coming out, but not the kinetic energy. I'm writing Ke. So this is what we observe for a photoelectric effect. Is it clear, the comparison between the wave nature and the particle nature, and why the wave nature is not able to explain the photoelectric effect, whereas particle nature is able to explain this photoelectric effect? Any doubt till this point? Then another question. This is a gold leaf electroscope. A gold leaf electroscope is a device that is used to detect the charge. So using this electroscope, we can find the charge. The deflection of a gold leaf depends on the amount of the charge on the zinc plate. So how much charge is there on the zinc plate? If there's a large deflection, it means more charge is there because like charges repel. So using that, we can identify how much charge is there. If there's a more charge, then more deflection. Like this, the gold leaf, they will have large spacing between them. This part is rigid. A conducting rod is a rigid. So the gold leaf, if they have the same charge, identical charge, like charges repel, either positive or negative. So they will move away. Greater charge means greater distance between the gold leaf and the conducting rod. Now what happened in a demonstration of a photoelectric effect? A teacher charged the plate with a negatively charged teacher charged the zinc plate with the negative charge, and the gold leaf deflected. So what teacher did? Teacher charged this the zinc plate. So as a result, because it's a conducting, so hole will get a charge. So hole will get a negative charge, like charges repel. So as a result, what happened? The gold leaf is deflected. Now then what he did, because teacher is demonstrating the photoelectric effect, means explaining the idea that when light falls on the metal, the electrons are removed from the metal if the energy of the incident light is more than the work function. So when ultraviolet radiation of a frequency 2 into 10 to the power 15 hertz was shown onto a zinc plate, the deflection of the gold leaf reduces. What is the reason why the deflection reduces? Because say this is a photon. So when we incident particle, light particle, photon, as the energy of the photon is more than the work function minimum possible energy to remove electrons, so these electrons absorb energy. As a result, when they absorb energy, they will go out. So when these electrons will go out, the number of the electron start to decrease. As the number of electrons start to decrease, what will happen? The repulsion will also decrease, and the gold leaf, the deflection of the gold leaf from the conducting rod will decrease. So teacher is demonstrating that this should happen if the light is having if there's a photoelectric effect, then this should happen. And if the light energy or energy of the incident light is more than the work function, then the leaf should collapse and it should stick to the conducting rod. Then explain why the deflection of a gold leaf reduces, and your answer should include a calculation. The work function of a zinc is given 6.9 into 10 to the power minus 19 joule. So what we have to do, we have to show that the energy of the photons which are coming or towards the metal, we have to calculate energy of the photon, and we have to compare with the work function the minimum possible energy. So what happen if the energy of the photon which we will calculate, if we found that it is more than the work function, greater than or equal to work function, there will be a photoelectric effect, and as a result of the photoelectric effect, the electron will go out and the charge on the gold leaf will start to decrease and the spacing will reduce. So we have to show by calculation how to get the energy of the incident. We have the formula E is equals to HF. E is equals to energy H is a Planck's constant, which is 6.63 into 10 power minus 34, and F is the frequency. So we multiply them to get the energy of the incident photon. So here energy of the incident photon is equals to HF, where H is a Planck's constant, which is a fixed value 6.63 into 10 power minus 34, a constant, multiplied by frequency, which is 2 into 10 power 15 hertz. So when we multiply these two factors, we will get the energy of the incident light, which is 1.3 into 10 power minus 19 joules. That is the energy. So we got the energy. Now we will compare this energy with the work function. So what is the work function given here? The work function of the zinc is 6.9 into 10 power minus 19. So the minimum possible energy which we need to remove electron. So 6.9 into 10 power minus 19 joule is there. This is minus 18. When we multiply, it will not be minus 19, it is minus 18. Now when we compare, you can see this is, we will compare the energy of the incident photon with energy, the work function minimum energy needed to remove electron. So energy of the incident photon is more and the work function is less. So if the energy of the incident photon is more than the work function, so yes, there will be a photoelectric effect. So when there is a photoelectric effect, so the answer here will mention the energy of the incident, the energy of the incident photon is more than the work function, the minimum possible energy to remove electron. So as a result, what will happen? The electrons will come out from the metal surface and the charge on the gold leaf will decrease, and as a result, when the charge on the gold leaf will decrease, the spacing will reduce between the conducting rod and the gold leaf. If the energy of the incident photon was less than the work function, then there will be no electron coming out from the metal. And if there is no electron coming out from the metal, then the gold leaf spacing between the gold leaf and the conducting rod should not change. But because the energy of the incident photon is more than the work function, that's why the charge on the gold leaf is decreasing, which reduces the spacing between the conducting rod and the gold leaf. Is it clear, this part? I'll share another link and continue this discussion.